Good morning, everyone. Sorry I'm not at school today, but as you can tell from my voice, not feeling so great. So I went ahead and made a video for today's lesson. It's kind of short. When you're done, just please work on the worksheet. You can work on it with your groups, but then when you're done, please work on other homework and or read a book. Okay. So we are starting a new chapter today. So the lines in the plane and parallel lines. Okay, and today is just going to be basically about circles. This upcoming Friday, we have a quiz and it's the end of first quarter. All late work and absent work needs to be in by this Thursday. Okay, so all late work, absent work by Thursday. Okay. All right, so let's go ahead and start the lesson. Okay, so circles. There's different parts of the circle that we need to know about. Okay, we have our word bank over here to the right. So, and you guys probably know most of this, but the number one, this is the radius. Okay, so remember that the radius starts at the center and goes to a point on the outside of the circle. Okay, number two is the diameter. So a diameter goes through the center and has endpoints on the outside of the circle. In the middle, that's known as the center of the circle. And then all the way around the circle is known as the circumference. So you guys are used to hearing perimeter for any type of shape, okay, any type of polygon, but for a circle, it's known as circumference. All right, let's go ahead and fill in these words. Sorry. Okay, so a segment that connects any 2 points on a circle and passes through the center. So the key word here is that it passes through the center, and there's 2 points on the circle. So that is going to be the diameter. A segment from the center of a circle to any point, so it's starting at the center and goes to any point on the circle, is known as the radius. And the perimeter, like I was just mentioning, around the circle is the circumference. So if the diameter is the length from one end of the circle to the other through the center, then half the diameter represents the radius. Okay. So then going in the reverse direction, twice as long as the radius would be the diameter. Okay, now we're going to skip number 10. Alright, so it's really important that you guys know the parts of the circle because we're going to be using them in our proofs. Okay, so a couple other things we need to talk about is what we remember about a circle. So what is the formula for the area of a circle? Anyone remember? Good. Area equals pi r squared. Okay, and then what is the formula for the circumference of a circle? The way that I always remember it is twinkle, twinkle, little star, circumference equals 2 pi r. Okay. And then it says, what is the relationship between the diameter of a circle and the radius of a circle? So we kind of answered that earlier, but the diameter is equal to 2 times the radius, or the radius is equal to 1/2 times the diameter. So another way we can write circumference, okay, is if you look at number 2, you have 2r, well that's the same thing as d. So circumference also equals pi times d. Alright, moving to this page of our notes. Okay. When it says, how would you define a circle? Basically, that just means, like, how would you, there's really no, like, no corners, no edges, right? It's circular, and sorry, I had to pause to cough, but it's circular, right? There's really no start, there's no end, it's just continuous. Okay, so when you name a circle, if you heard that, that was my dog, Wrigley. To name a circle, you look at the center and you would say that this is circle P. Okay, kind of hard to draw a circle on the iPad, but circle with the center P. Okay, and then all the radii are segments. So PA, PB, and PC are all the radii of the circle. Okay. And the useful theorem that we are going to be using is that all radii of a circle are congruent. Alright, so if we look at our one proof, so you're just given that this is circle P. Okay, and using the theorem that we just spoke about, we know that all radii are congruent. Okay, so we would say that PD is congruent to PA, and PC is congruent to PB. So all radii of a circle are congruent. Okay, so we're trying to prove that AB is congruent to CD. Okay, but they're not radii. So we have to prove that these triangles are congruent first. Well, we also have that vertical angles. So angle CPD is congruent to angle APB. So vertical angles theorem. And now we can prove the two triangles congruent. So triangle CPD is congruent to triangle APB by side angle side, and the order would be 2, 3, 2. Okay. But we're not done with the proof. The proof required us to prove that AB was congruent to CD. And remember that in order to use CPCTC, you have to prove that the two triangles are congruent. So in step 4, we proved that the two triangles were congruent. So in step 5, we can now say that the parts are congruent. So AB is congruent to CD by CPCTC. Okay. So basically, you need to know the parts of a circle and the fact that all radii of a circle are congruent. Okay, so once again, you guys can work on the homework in groups. Okay, when you're done, please find something else to work on. So if that's reading a book, working on another homework in class, just please don't be a distraction. And then on Wednesday, we will take a look at your Chapter 3 tests. Okay, thank you. Have a good day. Bye-bye.